All right, good evening, everyone. Thanks so much for joining us for this late session. My name is Ann Fitz. I'm a product engineer on the JavaScript SDK, and I'm here with Heather, who's also a product engineer on the SDK. And is this just me, or is this really loud? Today, we're going to talk to you about ArcGIS Maps SDK for JavaScript using Arcade with your apps. So just out of curiosity, how many of you are familiar with Arcade, have used Arcade before? A little bit? OK. How many of you are just getting started? OK, awesome, great. Well, this should be a good session for you. We'll kind of start out, just so everyone knows where we're headed. We'll kind of start out with the demo of some of the Arcade basics. We'll talk a little bit about what Arcade is and why you should be using it and when you should use it. And then we'll get into a demo of some of the Arcade basics. So for those of you who have used Arcade before, some of those concepts might already be familiar to you. And then we'll talk about how Arcade can be used in the JavaScript SDK. So we'll get into some of the profiles where you can find Arcade, and then we'll just jump into a whole bunch of demos and show you guys some fun things. So to start off, we'll talk about what is Arcade. Excuse me. Arcade is an expression language that gives you the flexibility to define custom content in your ArcGIS applications. And it can be used to calculate and format data values, to enforce rules, generate content elements, or do any of the above things conditionally. But at its core, Arcade is a calculator. It takes in input values, it runs the expression or performs some sort of calculation, and then returns you an output. And Arcade works the same across all ArcGIS applications. So you can write the expression in ArcGIS Online, and you'll get the same result in ArcGIS Pro and dashboards and any of the developer SDKs and more. So as I mentioned in the last slide, Arcade is portable, meaning that the same expression will produce the same result across all your ArcGIS applications. It's also lightweight, so the scripts and expressions will execute quickly and efficiently. And the thing that's most unique about the Arcade language is that it was designed to be geospatial first, meaning that the geospatial data is a first-class member. And the language contains feature and geometry data types and provides specific functions that allow you to easily work with those data types. And lastly, Arcade is secure. So any expressions that you use will not compromise the security of your applications. So now that you have a better understanding of Arcade, you might be wondering, when should you use it, or why should you use it? Well, Arcade is most useful when you don't own the data. And this doesn't mean like you can only use it if you don't own the data, or you have to use it if you don't own the data, but it just gives you the ability. It may mean like if you don't have the ability to create new fields on the data service, you can still use Arcade to perform calculations on the client side that won't alter the original data. Number two, if the data is frequently updating, Arcade will always take in the latest values from your data when running an expression, so your expression will always stay up to date with your data source. Number three, you want to view your dynamic content in other applications. I've mentioned this a few times already, but Arcade is portable. And one of the main benefits of using Arcade is that you don't need to write the same expression multiple times for it to work in your different applications. You can just write it just once, save it to your web map, and use it in any other ArcGIS application. And number four, if you want to work with feature data to create custom content in your apps. Arcade has many built-in functions that allow you to easily work with the feature data. And you can leverage this when creating dynamic content in your applications. OK, so now that you have a better idea of what Arcade is and when you should use it, I'm going to pass it off to Heather, who is going to give you a quick guide to the Arcade language and its features.
Awesome. Good? Mm-hmm. Excellent. All right. So before we even get started, just even with the basics, I wanted to point you all to the just the documentation site. So if you take a look at just the developers, ArcGIS.com, Arcade, you'll notice here on the left-hand side in the TOC, we have a listing of all of these language features. And these are pretty much just the basics. So if you're brand new going into this, this is probably the first place that you're going to go through and just kind of get spun up on so you can get a good understanding of what to do as you get started. You got your statements, comments, your returns, your variables, data types, and so forth. So let me go ahead here and show you what we have. So who here has worked with the Arcade editor? Anybody? Does this look familiar to you guys at all? A little bit?
You might have seen it in the map viewer before.
Yeah, so we have this, it's embedded. We have this now, it's like within the map viewer. Field Maps has it, Dashboard, and a few others as well. This is a standalone. I just have this isolated on my machine, but it's basically going to be comparable to what you would have if you were working in something like the map viewers. So first things first, I have it set up here just to show some of the basics. So we have our hello world, as you know, any good person starting any type of language, you know, we love our hello worlds. So as you can see here, we have our implicit returns. So, you know, I can sit here, run it, shows up in my console, or not my console, my output, have my hello worlds. All right, pretty straightforward. We can also do our explicit returns. So if I go ahead, set some variables, go ahead and run that. It will always tell you the data type that you're working with. So in this case, your number, and then the value of this. So I have my X value and my Y value showing up here, and explicitly setting that. So I'm going to go here now. Make sure I don't get lost in all of this. We can also return some built-in functions. We have a ton of functions that the Arcade editor comes pre-built, a couple hundred actually. I know I've lost count, there's a lot. It's a pretty basic one. You'll notice here we have the Intellisense that pops up. It automatically sees here, okay, I've got 3 different ways of doing this. Any of you guys who've ever worked with any type of editors before with the Intellisense, it's all pretty straightforward. Should look pretty familiar. So if I go in here, I can say, all right, I want my sum. And based on what it is that you need to work with, what the type of data is, the type of calculations, it'll give you some suggestions. I feel like this is really loud. Sorry, guys. All right, and as you can see, same exact thing again here. So I'm just returning the sum of X and Y, so 7, 5, 10, 17, quickly. Again, like Ann said, it's just a calculator. Let me go up here and show you a few more. Okay, we can chain our functions. So we have a straight console, nothing fancy. Go in here, I have an array of 2 hellos. Again, nothing in my output, my console, a couple hellos. So again, I mean, this is all very basic for some of you. Some of you, it may be very new, but really just wanted to show you some of, you know, the basic functionality going into this, as these are the fundamentals, especially if you are just getting started. We have multi-line expressions that you can put in with multiple statements. So in this case, we are calculating a ratio, passing in values with your index. Sorry, I didn't have it all in here. I did this earlier, didn't I? Ann's like, yeah, you did that earlier, Heather. Yeah, there we go. So it's providing a ratio of 1/3, 0.33.
So in this part, Heather's just showing how you can, as developers, can write your own functions in Arcade. So it's not just limited to those built-in functions that we provide for you. You can also write your own functions, and sometimes this can help save a lot of code, because we've seen people share arcade expressions with us that are like hundreds of lines long, and then by just creating a function and passing in a few variables, it can really help clean up your code. So, sorry, Heather.
No, it's true. I did it yesterday. I had Christian. Some of you may have seen Christian and Ann up on stage doing some demos and having some issues on my end with some other expressions that I was running, and he was like, "Yeah, we can clean this up." So yeah, there's a lot you can do. All right, so a couple more here. And again, just showing you all the fun bells and whistles of the editor here. We have our loops and conditionals. So, again, very basic, but everything that I'm showing you all, we have this here in that documentation site, okay? Template literals, data types, operators, if else, loops, all with the documentation, what's needed, examples, and so forth. So I'm just going to show you a couple more. All right, so you'll notice here if I start typing, hold on here. Sorry, guys. Automatically populates. So that's also really nice, because if you're anything like me, you will forget a bracket somewhere, you will forget to end, like I get lost in brackets. So just having that nice little code, code helpers, the snippets that come in, it's, little things, but the little things make a big difference when they add up after a while. So we already have that. Run it, and I probably am missing something else as well. Yeah, there we go. There we go. So again, just looping through, dividing by 2, and then providing that result. All right? And then, okay, so don't bore you too much with a bunch of console statements. So I'll just do a few more here. So that's one part that I wanted to show you. So what you'll notice here, if you guys do work with the editor, we have a listing here on the right-hand side for our profile variables, the functions. So I talked a little bit about those functions earlier. We have the listing of all of these. So again, you got some. I can go in here. I can click on this. It will show me a definition or description of what it does. It tells me the parameters that I need to do to pass in, what the return value is, and it even provides some examples. I use these snippets on a regular basis because I can never remember all of them. There's so many. All right. And then we also have suggestions, and these are pretty awesome as well because it'll give you basically just little snippets to kind of help get you started with your code. So in this case, I have a couple in here. I just want to show I've got a dictionary, and we'll be working with the dictionary, and you'll see this later with some of our demos as well. But in this case, I have a pre-built dictionary that I'm bringing in, and all that dictionary is pretty much just like, it's an object. It's an object that holds a bunch of different key value pairs. So I have, you can have a Boolean, I've got an array, I've got a long string, I have a float, text, and a date that I have passed in this case. And all I'm doing is, as you'll see here, that dictionary, and you can actually go in and you can access the dictionary like you would any object. So by going in, in this case, DICT, dot notation, provides you your, the fields or whatever, the key values, like the keys that you pass in. Provide that. Same exact thing, if you can use the dot notation, you can also use bracket notation as well. And the bracket notation is very, very helpful if you're working with like the long string names. Again, a lot of stuff that we're I'm tossing out here, all of it is in the documentation, every single thing about the dot notation and the brackets and when to use and when not to use certain things, it's in the documentation. All righty. Just a couple things here, and I know Anne has some fun things she wants to show you as well. All right, so kind of what what arcade, like the bread and butter of what all of this is about is the geometry, right? So you can actually create geometries like this on the fly as well, like basically faking your data. You can use it for like testing and so forth, which I've done before in the past as well. In this case, I am creating a polygon shape. I'm passing in some rings with some XY coordinates and that spatial reference, and then I am using the centroid function and then passing that shape reference in here. You can see here, it gives me back the geometry type, again, the data type, and in this case, it's geometry, that's what we're working with. The type is point, and then the value of the spatial reference. We have a feature and a feature set. Okay. And you'll see here again, we can also go ahead and just generate these on the fly. Again, many times if you need to try to mimic some test data or so forth, you can do that within the editor as well. So that's all I'm doing is I'm creating a brand new feature. The feature has geometry, so whatever it is that you're working with in this case, it's just a point, XY point, and then my attributes. So I've got 2 attribute values, a rank and an elevation, and then I'm just consoling it out. That's it. So I have the value, I have my feature value then. And then lastly, we have a feature set. And all a feature set is just a collection of features. That's it. So in this case, we're creating one on the fly using, in this case it's called JSON Dictionary. We are creating a feature. We're passing in the spatial reference. We're telling it the geometry type. And we're passing the features in because the feature set is just an array of, or collection of features. So if I run that.
I'm missing the feature from the list.
What am I doing?
That one should be it before.
Hold on here. Do I need both in here?
Yeah.
Oh, very good. Thank you. I had that in there earlier. It's getting ahead of myself.
Yeah, so this is an example of a manually created feature and feature set. This is probably not something you're going to run into all that often. I think typically you'll reference, there's all sorts of functions that allow you to bring in your feature set from a portal item, or you can access it in some of the profiles, and we'll get into that a little bit more soon. But yeah.
Yeah, so I kind of just dumped a bunch of information, but mainly I wanted to show you, so if anything to get out of this, the Arcade editor is really robust. There's a ton of stuff you can do with it. This, again, in this case, I just have it standalone, but if you've ever worked with the map viewer, field maps, dashboard, so forth, it's there. You can get access to it, work with it in there. You can access the documentation, help snippets directly within it. So I showed you here within the functions. And then the help itself. I mean, there's so much information in here. When in doubt, I always kind of drill in on this when I do talks, but we try to keep this stuff up to date. Christian and Anne have done a fabulous, and Omar have done a fabulous job updating the Arcade doc and making sure that the information is, up to speed with what's available and, limitations and so forth.
Yeah,
so.
And that editor is also available here in the doc site if you click on the playground.
Yep, I have that up, and thank you for reminding me.
So it's there. I find this really useful, especially when writing arcade expressions in JavaScript apps. If you just want to do a quick test and make sure it's working, because the editor provides error checking and auto completion. So I find it really useful for writing arcade and then copying it into my JavaScript application. But yeah, thanks, Heather. Will you switch over back to my machine? Okay, great. So now we're going to get into talking about arcade profiles. So what's a profile? A profile defines the context in which the arcade expression is evaluated and interpreted. And many times, the profile refers to a specific application in which you can use arcade, or an area of an application where arcade can be used. So each profile will specify the execution context, profile variables, function bundles, valid data return types, and also, I don't have this on this slide, but the time zone and spatial reference. So I'm going to switch over to let's see if I can do this correctly. Is that tiny? Back to the doc, just so you can see an overview of all of the profiles where you can use Arcade. So it really is a lot. There's only a few of these that we'll focus on in the JavaScript API in today's session. But for example, like each profile page in the doc will specify where it can be used. So the context, you see all the different products. The spatial reference, so it matches the spatial reference of the map where you're executing the expression, the time zone, any profile variables that are available to you. So you can use these in your expression, and it gives you a description of what they are. So you can use the dollar feature, and that references the feature that's, in this case, getting visualized. And you can also access the view scale. So whenever you're working with Arcade, definitely recommend checking out these pages to know what is available to you. We also specify the function bundles, so I'll get into that in just a second, and then the valid return type. So for the visualization profile, you can only return either a text or a number in order to visualize your data. And we'll show you some examples of that in just a second. So I'll switch back over to my slides. And yeah, as I mentioned, the function bundles. So each profile is defined with a set of function bundles. And this just describes the set of functions that are included with that profile implementation. Most functions are just in that core bundle, but other bundles will have a more specific set of functions. So all profiles will implement the core bundle, and that includes, like, you can see that includes the constants, the array functions, data functions, feature functions, et cetera. So there's a great, if you go to we keep referencing in the doc, but we think the doc's pretty great. If you go back to the doc, you can see what all the functions are supported in each bundle. So just to give you an idea of how the function bundles and profile variables work within a profile, we'll take a look at this case study in the labeling profile. So our input, this dollar feature, that's our profile variable for the function. And that we can see this is some weather data. We have the air temperature, humidity, et cetera, et cetera. And so that's our input to our profile. And then in this gray box, we have our profile where we have access to those core functions and the geometry functions, because that's what's supported in this labeling profile. And in our expression, all we're doing is a very simple getting the air temperature of the feature and converting it to Celsius, and then returning that as a text with the degree symbol. So that text is one of those core functions that we have access to in this profile. And yeah, then our output is just 3 degrees Celsius. So that value from the feature returned in a formatted way. Okay, so now that you know a little bit more about profiles and Arcade, here's an overview of all the Arcade profiles you have access to in the JavaScript SDK. So the first row is going to represent the profile context. I guess I had way too many animations. We'll just skip through that. So the context, the profile variables, return type, and function bundles. All this is mentioned in the doc pages. So next, we're going to go into each of these profiles in a little more detail and show you some demos. So let me switch back over to my, here we go. So we'll start with the labeling profile. And why does it look like that? OK, there we go. So pretty much in all the places you can use Arcade in the JavaScript SDK, you'll see the word expression. And that's always, I think always, I'm like thinking in my brain to make sure that's right. But that's always going to refer to an Arcade expression. You'll see expression, expression info. That's always referring to Arcade. So in this map, I have that weather data again. And this is what the raw data looks like. It's this big long, not rounded number with lots of decimals. And so this is an Arcade expression here. All labels use Arcade expressions. All we're doing is getting the temperature of the feature. But we can take advantage of some of the Arcade functions that we have available to us and round the feature and add on some simple text concatenation, add on degrees Fahrenheit. So this can help, clean up your labels a lot, and it's just a very simple use case for Arcade. Taking it a step further, we can convert that to Celsius. And all of this is just like, basic calculations. We said at its core, Arcade is a calculator. So just doing that calculation and formatting it with the text function. So passing that number in here in place of the pound sign and adding on degrees Celsius. But that's not all you can do with labels. You can also create more complex expressions with multi-line labels. So again, in this example, we're looking at weather data, but showing multiple attributes on multiple line labels. So you can see here the weather station that's referenced, the temperature, the wind speed and direction, and the relative humidity. And this is done through this Arcade expression right here, where we're getting all of those attributes directly from the features, performing some calculations. So this when function allows you to kind of do a when it's this, then this, when this, then this. So checking if when the degrees are certain, in between certain values, we can parse that into like north, northeast, southeast, et cetera. We'll get the wind, we'll get the temperature, all of this together, and then we can concatenate all of these different labels onto a new line. And then in our JavaScript code, it's again, we're just referencing that label expression info and pulling that in right here. So a lot of times in JavaScript, there's a lot of ways you can write Arcade. Typically, we'll reference it in a separate script tag up at the top and then just pull it in. But you could also have it in a separate file, or you can write it directly in line in the code with template literals or anything like that. Okay, those were a couple of labeling demos. I think I had one more. Actually, no. So another profile within the JavaScript SDK is the feature Z profile. So this allows you to set the order or the elevation of features in your map. So I'm going to show you a couple of different implementations of this profile. And the first is with in 3D data, you can use an expression to offset your features from the ground. So here we're looking at just some air balloons, and you can kind of see if we oh gosh, I'm not using my mouse, and it's not happy with me. I'm trying to rotate the scene. But you can see that these features are all floating above the ground, and that's happening because of this expression. We are getting the dollar feature, which is representing each of these hot air balloons, and using that Z value to place them off the ground. We can, if we wanted to exaggerate the Z value a bit, we can use, multiply it by 10, and we can see, if I zoom out a bit, we can see those features are much higher up. So that's just one use case, very simple. Another 3D use case of this, a more realistic use case, is this example that's using a GeoJSON layer for the train station in Zurich. And so we can use Arcade to create different levels in our train station. So we see the overview here, but we can move below the ground, or see the ground and move below the ground, and see each of the different features available. And this feature Z is allowing us to visualize these features in different space in 3D. So this filter is we're showing all the features, but also only showing the labels for a specific layer at a time. Sorry, okay. And then this is also available in 2D, the feature Z. It's not with the elevation as much, but you can use it when sorting features. So in this example, we're looking at California fire perimeters, and we can use Arcade to update how we sort our data. And this is using that same feature Z profile. So if I go here, this is just done through the order by function, or layer.orderBy property. And you can either pass in a field value if you have a numeric field, or you can pass in an Arcade expression. So here I'm just finding the difference, the date difference between the alarm date and the date the fire was contained, and using that to display the difference there. Okay, Heather, do you want to go, and then I can switch back over to mine after? Okay. So Heather's going to talk to us about pop-ups and forms.
Alrighty. You guys hear me? Yeah, this is awfully loud. Okay, so I'm going to talk specifically about how you can work with Arcade and create custom Arcade expressions to customize your pop-up content and form content, or how you want to interact with your forms within the editor, JavaScript editor. So first things first, when working with pop-ups, we have 4 different types of elements that you can work with, or 4 different profiles. We are going to focus primarily on the pop-up element and the feature reduction pop-up element for my specific demos. Things that I want to show, though, is based upon how you're working with your pop-up and what type of data it is that you're trying to access. That's the profile that you need to focus on, or to look at when you're trying to figure out specifically what you get access to within that profile. So if we take a look at the pop-up element, so any of you guys work with the pop-up template just in general in JavaScript? Okay, so this would be like, in my head, I think, okay, this is just like a standard pop-up template. You know, you go in, it's just Esri pop-up template. You have your content, so forth. You can set expressions in there. Very, very similar. And then you have, in my other case I'm going to show you is the feature reduction. So we also have the ability to set a pop-up template within feature reduction if you're working with like clustering data and so forth. So in this particular case, if you take a look at the documentation, just wanted to compare the different, the profile variables that you have available to you within, based on what profile it is that you're working with. So in this case, the pop-up element, not the clustering one, just the element, I have access to the feature, layer, map, data store, user input, and graph. Now, if I'm just going to be working directly on the feature reduction, so when you click on a cluster and that pop-up that shows, I have access to the feature itself, and I have access to those feature set of all those aggregated features, so the cluster of all those features, so I can get access to those. All right, so with all of that said, let's actually look at one. Okay, so what I have here, this is, I created this, first off, I created this in Map Viewer just because, and I wanted to kind of go back and forth to show you the simplicity of what you can do and what you can do to try to troubleshoot if you're having issues as well. So I created this data to show if anybody here likes or knows about there's a total solar eclipse happening in a couple weeks. So what this is data that I pulled from NASA that shows the path of total darkness, so when the sun is completely covered, and the times of when it happens. So what I have is basically, this is clustering of cities that fall within the path of totality for this eclipse. And what I did was I created a cluster rendering of these cities, but by looking at this, I mean, it doesn't really tell me a whole lot. I've got some labeling, but you know, what exactly is this? So if I go ahead and click on one of these, you'll notice that now I actually have a pop-up that gives me a little bit more information to work off of. It tells me you've got my cluster, represents 560 features that fall, and then in addition to that, I also have another expression that I used that went in here and basically iterated and grabbed the distinctive values of all the states that fell within this cluster and how many cities within each of these states that will be able to experience the total solar eclipse. So this would be considered the feature reduction, the pop-up profile. So I have access to the aggregated features, and I have access to the feature itself, okay? Now I can actually go in here if I say, all right, well, that's great and all, but I want to be able to, you know, probably don't want to go in and scroll through all 561, but you might have something with a few less. You can click on them individually, and you can actually customize then what you want those individual pop-ups to be. This is that straight pop-up, that pop-up template, so if anybody's familiar and you've worked with that before, just standard JavaScript, this would be comparable to that. So in this, I have access to the feature as well. I have a little bit more to work with, but what I'm doing is I'm basically running a script that goes in, calculates the time, and I do a little bit of formatting as well to kind of strip and make the dates a little bit easier to read. And I also go in and I have another expression that creates this table. So just generates an HTML table, and then I insert that into this, this arcade expression element, basically. So if we take a look, this is the actual app that I created doing that. So same exact thing that you just saw. I have this here within my standalone app, and same exact thing. The reason I wanted to show this was because this demo, I actually did this for one that I showed yesterday, where I was using data, not feature layer data. I was using data, we were using GeoJSON. This data, this was OGC, feature layer data, which you can actually, again, the same rules apply, that you can create these pop-up templates, the clustering templates and so forth, and you can apply this directly to this OGC feature layer. So if you go in, nothing got carried over from that web map. I'm not referencing the web map, although that'd be awesome and really easy to do. It's not always possible for some people. So what I have is, if we took a quick look here, you'll notice there's a lot of lines, but I have a couple parts where I have two functions. I have one where I create the actual pop-up template, and I have another one where I create that cluster. And you'll notice within that pop-up template, it's very, very similar. We have the content, so if you guys have worked before with the JavaScript SDK, you have different particular elements that you can set, same exact thing. So we have a text element where I have some expressions, and I also have an arcade expression element as well that went in here. And you'll notice that I have this arcade expression that goes in, does some formatting, a lot of date formatting, builds out that HTML table. You can see here I'm working with some template literals, so I can grab whatever value it is that I access from above for that formatted time, and I'm passing that into my table. One thing I want to point out is this guy, these backticks. If you're working with template literals, you need to make sure that you add those backticks. I have to use an escape character since I'm working outside of the editor, the arcade editor. So once I created this using the arcade editor because it's easier, once I've got everything working the way I liked it, I copied it and I brought it then into this code from there. And then just making sure then, because I have those ticks, I have to escape that.
Yeah, it can be a little tricky sometimes because template literals are a really easy way to write your arcade expressions in JavaScript, like within template literals. But Arcade also supports template literals. Yeah. So that's what Heather's running into here. She needs to escape her template literals within her arcade expression because everything's already wrapped in template literals. So.
And I will have
something to look out for.
I didn't mention this before, but if you guys are interested, I have this up on my GitHub. I can point you to the URL later on if you want to take a look and just actually dig into it and play around with it a little bit. Yeah, it's a lot. I know there's a lot of stuff in here, so it's always like, just get the information after this, and you can go and spend some time and dive into it if you want to. I have some labeling as well in there, so we're not going to talk about that right now, but if you want to, you can take a look there as well. Same thing goes with the reduction, that create feature reduction. I want to take a look here and make sure I grab those aggregated ones, and give me a moment. All right, this is what I need. Sorry guys, I thought I had that up. All right, yep, there we go. Okay, so this is the one where when this is the expression that I'm running when I actually go in and I initially click on this. Okay, so this is the aggregated features I have access to. Okay, and then when I drill in, that's the pop-up template. So again, I'll have all that code out there. If you guys want to take a look, you can play around with it, you know, see how things are all broken out. All right, so those are pop-ups. Anybody here use editor, form, anything like that? Great, okay. So it's not a new thing, it's newer, I would say, than some of the pop-up stuff. But we do have a couple profiles that you can work with as well with forms, and basically it can help make your editing experience a lot more enjoyable and a little bit easier. The first one is the constraints. So if you work within the JavaScript SDK, that would be like comparable to setting like a visible expression, setting a required expression, an editable expression. Those are constraining whether or not, it's like a true false that returns. It basically, an expression that tells setting an expression up that tells how you want your form to be able to be interacted with, right? Do you want a certain element to be visible? Do you want your attribute to be visible? Do you need to have a required field based upon a condition from another field? You can set that up here using form constraints. These are the profile variables that you have access to that. Feature, original feature, that's going to be what the value was of that before you made those edits. And anybody that does any type of QA work or working with the form analysis and the form expressions, you'll probably work with this at some point. The edit type, so you're checking to see the type of edit. You creates, updates, inserts, things like that. The layer, the data store, feature set, and the map. And then secondly, we have the form calculation. And the calculation, all that is just a value expression. So if you take a look at, if you go into, in the SDK again, this would be comparable to working with your value expressions. You can go in, you can set up how you want a certain field to look and show based upon an expression that you have set within this arcade expression that you have set within your code. So I'm going to show you a couple samples. You can see what we're talking about here. So again, I'm going to show you first, we have a web map. This web map is just, again, it permits parcels. It actually has some relationship stuff set on it too, so I'll show you a little bit of that. What I'd like to show you is this application. So this application is actually pulling in that web map. The web map has that form information saved within it. You don't have to do it that way. We actually have a sample. I can show you guys more at the end as well if you're interested, where you can actually write everything out and do it that way as well. If you save everything within the web map, it makes it a lot easier when you're bringing that application in, because all of that form information, including those arcade expressions, automatically get passed in with that web map, so you're not having to recreate everything. So in this particular case, what I have is this web map. I'm going to do some just very basic editing. Go in here, and I'm going to create just this parcel. All right. And what you'll notice here is automatically I have a value expression, so I have a form calculation profile, expression that would be under that form calculation profile. That it would be, that's used for this parcel ID. Okay, so it checks basically to see whether or not if it is empty. If it's empty, go ahead, randomly generate a number, and then add that number in here. Okay, and then secondly, we have the visibility. So you'll notice here that the commercial, I don't have anything set for the parcel type. Once I have a parcel type set in here, the remaining portion of the fields show up, and that's just based on the form constraints. Okay, you'll notice I have the area that automatically gets populated. All of that is, again, just another expression showing me the parcel area. And this area is a function, another one of the magical functions that are provided through Arcade, right? One of the hundreds of functions that we have. Alrighty, and we are getting low on time, so I'm not going to go through every single one of these things, but all of this will be up on that GitHub site, and I will also be around later if anybody wants to actually see it and go through it too. But again, just realize that you have the ability to constrain, and you have the ability to provide and predefine values for how you want specific fields to be. Okay, and I think that's all I had to say.
We pass it back.
Yep.
All right, we are running a little bit low on time, but there's one more profile, and that's visualization. And so I mentioned this one a bit earlier. The return types for visualization are either text or number. And so in this case, we're going to use the visualization profile with, I believe this is a unique value renderer. And we're going to use Arcade to create predominant categories. So in this example, we're looking at the predominant political party based on the number of voters in each county. And this is, each of this data is stored in a different field. So the Republican is in one field, Democrat is in another field, and Independent is another field. So we can put these all into an array called parties, use the max function to find which of those three fields has the most, and then run a decode function. So if the Republican field is the most, we'll return Republican, and so on. And then we can use those as our unique values to visualize our data. We can also, well, that's kind of a similar example. I'll skip ahead. We can also use Arcade with the visual variables. So in this example, we're using the calculated wind chill, I believe, or yeah, apparent temperature and measured air temperature. And so this is, again, just another Arcade expression where we're calculating the wind chill and the heat index. And it's kind of a more complex expression. But in this example, we're just applying that to the color visual variable. So passing in all these stops and the labels and the colors, and then using this Arcade expression to make that calculation. There are a lot of really fun things you can do with Arcade too, and I won't get into all of this today, but Arcade can be used in primitive overrides with sim symbols. So you can, in this example, I'm overriding the speed of the animation, and if the symbol is animating based on the air quality, so any hazardous air quality will be animating, whereas anything that's not hazardous won't. And this is just another fun thing I did using Arcade. This is a visualization of one of my colleagues who's a race car driver, and this is just creating using visual variables to create kind of like a trail behind the car as it drives. And it would help if I pulled up the code properly. So in this, just calculating the difference between the ending date on the time slider and the current date of the feature, and using that date difference function and using that to create my stops. Okay, so switching back over, if I can get to my right slides, to the slides. Yeah, so that was just a few profile demos. I know we only have like 10 minutes left and I still have a lot of content to cover, but we did introduce Arcade APIs recently to allow you to execute Arcade on your own terms. So if you have a use case for Arcade that's not in one of the predefined profiles, or if you need to use the result of an expression outside of the original context, or if you need to define a custom Arcade profile to provide a configurable experience for your users to write their own Arcade expressions. Or if you might want to use this if you just want to take advantage of Arcade's simplified language syntax. There's a lot of different opportunities to use this Arcade API. I'll go through just a few of these examples just really briefly. Oh my gosh, that's really zoomed in. Okay, So this is just a simple example where we have this web map that's been written with an arcade expression. And what we wanted to do is get the visualization of this expression to show the same way in our chart. And so this is an instance where we're using that arcade API, and we can, if we zoom in and we want to update the chart based on what's currently in our view, we'll pass in that new information and everything. And my colleague Christian wrote like a really great blog on this that will walk you through it all in detail. Oh, I am not sharing my slide. You guys didn't tell me. Sorry,
do the same thing.
It wasn't mirroring my screen. This is what I was just showing, and none of you saw it, so I'm sorry. This is the web map and the chart, and we can update the chart based on what's currently shown in the view. I'm so sorry about that. This is the blog I was referring to, so it's really, really great. And then here's another example, another blog written by my colleague Christian about creating a custom arcade profile. There's some really good stuff in there. And here's just a quick example of kind of what that would look like. So in this example, we're just creating a custom profile to take advantage of some of the simplified language syntax. So Arcade provides a lot of really useful functions for working with dates. Specifically the date difference function, just pass in 2 date values and it gives you the result, versus like in JavaScript, it's a little bit more complicated to write. So this is showing how we can create a new profile. We're creating a profile variable called time extent, passing in a dictionary, but that time extent is representing a start and end date, and then also another profile variable for the unit. Then we'll write our expression, which is that date diff, using that date diff. And then as I update the time slider, we'll create the arcade executor, passing in both the expression and the profile. And then as I update the time slider, we'll calculate the time extent. So execute that arcade expression and pass in the time extent, the start and end time of the time slider. And so you can see as I make changes in the time slider, we see this time interval updating. And so that's just a very basic example of using a custom arcade profile. If you are interested in, or you have an idea for creating custom profiles, definitely let us know. Like, we want to hear about that. And yeah. And then the final thing, I won't show the slide because I already am here in my app. We've recently introduced the Arcade Editor as a web component. So Heather did a great demo of the Arcade Editor earlier. It provides a lot of useful features such as code completion, error checking, inline documentation, so much more. So if you are writing an app where your users are writing their own arcade expressions, if you have like some sort of map view, like a map maker app or something like that, you could take advantage of this. And yeah, I won't get into the code right now. It's one of those web components that you saw demoed in the plenary. So it's pretty simple to set up. And again, if you have a use case for this, we are very interested to hear about that. So definitely let us know. And yeah, it's available in the ArcGIS coding components package. You can either use it with an existing profile, or if you are creating a custom arcade profile, you can do that same thing with the Arcade Editor. And so that's it. Sorry for going almost all the way to the end of time. We have some we got some minutes for questions, but we have some resources here available to you with the Arcade documentation. There's a great guide page in the JavaScript SDK, and a lot of great resources there. I forgot to include the link to my GitHub that has all the samples I showed today, but I can put up a QR code so you can see that. And before we get into questions, just wanted to let you know to share. Oh, I can go back to that slide. I saw you taking a picture. Please share your feedback with us. Let us know if this content was relevant to you. Was it too beginner? Was it too advanced? Like, that stuff that really helps us tailor these sessions to you for next year. So yeah, that's all. If anyone has questions, we'd be happy to take them now. Yeah. Uh-huh.
Would it be possible to have like a, I guess, a database-driven content, make it dynamic to, I guess, maybe like a feature layer? So if I enter this feature layer, I'll load in this template literal.
Uh-huh.
Would that also kind of work?
Okay, so I'm supposed to repeat the question for if people watch it later. So your question is can you create dynamic content in your pop-ups based on a feature layer template?
Yeah, and retrieve from like a, I guess, a database. So
Yeah.
I store that expression in the database and then use it into my, I guess,
Pop-up.
like a loop stats or Angular.
Okay. Yeah, so is your data stored in like a portal item?
Not really. So we're gonna connect in images from a different source,
Okay.
and but we have points like a feature layer has points like a police incidents, I guess.
Okay.
We want to attach like both to that.
Okay, so yeah, you can access different data to bring into your pop-ups with the feature set functions. So but those are mostly referring to if the layer is already loaded in your map, you can easily access it, or if it's a portal item. So those are easy to access. We have talked about adding support for some sort of web request in the future, but it's not available at this time. Any other questions? I'll go back to that resources slide for you. Okay, I can pull up my GitHub so you guys can, if you are interested in any of the samples that I showed, I'll pull that up for you all. But yeah, if there's no other questions, thank you so much for coming and enjoy the rest of your night.